Okay, so here we have the information given to us for the rat study. One thing I'm going to write in is the sample sizes. So there were originally 10 in each cell. Maybe I'll put an n equals just so we know what this is talking about. In the meat, there were two categories that were combined, so each of these cells now has 20. So as we were analyzing at the high level the differences between cereal and meat, there was a sample size of 30, and at the low level sample size between cereal and meat, the sample size was also 30, so it was equal. Now what we're doing is we're switching the direction, and so we're looking within the cereal, are there differences between high and low? So here our n equals 20, and then differences between within the meat and differences between high and low. Here our n is going to equal 40. Okay, and then the overall confidence interval for difference between two groups is the difference within the sample, that's our best guess at the population difference also, plus minus whatever our critical value is. The book just uses t. I'm going to use t star just to be consistent with what many of you have seen before, and then SE as a standard error. So this part right here is known as the error margin, and you'll be familiar with that on, say, political polls, where you'll see that maybe the difference between Republicans and Democrats on this issue is 10% plus or minus 3%. That plus or minus portion is the error margin. This right here is a critical value, and you would usually look this up on a chart or use software. And this portion right here varies depending on what type of confidence interval you're taking. But for us, it's going to be standard deviation like that. Okay. Now let's unpack this just a little bit more. The standard deviation itself is the square of the mean squared error. And you can get this from your output. So in the ANOVA table, the residual line, the one that's the residual, that's the errors, you'll look for the mean squared, and you'll get your value there. In this particular problem, it's 206.6, which gives us about 14.37 for our standard deviation. Here, our N1 and N2 are going to change depending on which confidence interval we're calculating. So let's set up the confidence interval for the cereal group, and we'll have one confidence interval for the meat group. Okay, so for the cereal group, our confidence interval would be the difference between the two cereals, which would just be 2.0 plus or minus. Here's where we need our critical value. And in order to get that, we have our total sample size for the entire thing, which is 60 minus the 4 categories there. So that would be 56. If we look up that chart at 95%, that 95% confidence interval with 56 degrees of freedom. So this is about 2.00. Notice it's total coincidence here that these two are the same. And then we have the standard deviation. So we're doing our standard error here. That's that 14.37 portion, standard deviation. And here we're going to have, within the cereal group, we just have 1 over 10 plus 1 over 10. So you could put 2 over 10. And that gives us our confidence interval there. Let me just go ahead and adjust this one. This we have 99.75 minus 79, so we have 20.7 there as our best guess of the difference between the two groups, plus or minus, and then this portion is not going to change. Same amount of overall degrees of freedom, same mean squared error. This part here will change because we're going to have in the meat group, our sample sizes are 20 and 20. So we have 1 over 20 plus 1 over 20, which would give us 2 over 20. And of course we could reduce this. We're going to type it in the calculator anyway. So when we put it all together, run through the calculator. Okay, so when we look here within so these are our numbers for the confidence intervals. When we look within the cereal group, so just looking at rats who were fed cereal, but we're looking at the difference between the high and the low, we're fairly sure that the high quality group was somewhere between 10.85 lower and 14.85 higher. I forget if we're talking grams of protein here or calories, whatever it was. We're not really sure which group in general the population would be higher. 0 is inside of this confidence interval of the differences, so we can't tell much. On the other hand, within the meat group, so within the rats only who were fed meat, we can be confident that the high quality group had between 11.6 and 29.79 higher than whatever the low group was. So in this case, we're pretty convinced that the high quality does make a difference, because 0 is not inside this interval, and in fact this interval is well above 0. Even in the worst case scenario, we have the high quality group outperforming the low by 11.61. So just to clarify, these are our sample numbers, but what we're really concerned about is feeding rats in general, either the difference between a high and low quality cereal diet or high and low quality meat diet, and in those cases the gains that we could expect in the population would be, the average gain would be somewhere between these two numbers for cereal and somewhere between these two numbers for meat.